bucka. Haha. You know the deal.
So we've looked at nonlinear relations in terms of their table of values. We've looked at nonlinear relations in terms of the graph and what the graph looks like. The next thing we're going to do is take a look at the equation. Well, coming up with the equation here, you may have recognized it if you take a look at the values that we have for x and the corresponding values that we have for y. There is an equation here where we are doing something to x to get y. Pause the video for a second and see if you can figure out what it is and see if you can come up with the equation. And if not, just go ahead and press play. Okay, so you probably recognize there's some patterns here in terms of how these values are changing. The first differences for y are different each time. But there is a pattern in terms of how much they're going up by. That's one thing. Also, what we're doing to x here, we're actually timesing it by itself to get y. So the equation that we have here is y equals x times x. Another way to write x times x is using exponents. So y equals x squared. Now this is a little bit different from equations we've seen so far in that here we have this exponent other than 1, right? So for an example of a linear equation that we saw was where we're getting paid $10 per hour, y equals 10x. Well, there are exponents there, and when I'm talking about exponents, I'm talking about with the variables. There are no exponents, but when there are no exponents, we assume it's a 1. So far we've only seen equations where the variables have an exponent of 1. Here with this relationship, we've got a case where the exponent with one of the variables is not 1. And that's another way to tell whether or not you've got a linear or nonlinear relationship. If you've got two variables and one of the variables is anything other than 1, you know you've got a nonlinear equation there. So what we're going to do next is take a look at some other examples of nonlinear relations. And so here I've got the graph of y equals x squared that we just talked about, left that up there. I'm going to plot a new function here, and let's try a different exponent this time. Let's try x to the power of 3. In the red there's our graph for y equals x to the power of 3, and we can see it's similar to y equals x squared in that it is a curve, but a couple of differences. It goes into this region down here. It sort of curves around the origin there and then goes down into that other region, into the negatives, unlike y equals x squared. But again, definitely non. So if we try a different one, this time I'll use the exponent 2 again, but I'll put a number in front of that variable. So instead of just x squared, it's 5x to the power of 2, and maybe I'll subtract 3 to see what that looks like. In the green, and we can see it looks similar to the first one. It looks similar to y equals x squared, but instead of starting at the origin, or sort of curves around down here at 0, -3, that coordinate there. But it does have that similar sort of shaped curve. But again, definitely not a linear equation. So these are just a few examples where we have an exponent other than 1 in our equation. And when we have an exponent other than 1 with one of the variables in in the equation, that means that we have a non-linear relation. So to finish off our discussion on nonlinear relations, I just want you to answer the following questions and identify each of the following as either linear or nonlinear. So there we've got 3 questions. The first one's just an equation. The second one is your table of values, and the third one is another equation. Now with the third one, I might suggest you use a graphing calculator of some sort. You can probably find one online for free to graph that, whether deciding or not it's a linear or nonlinear equation. If you're able to answer those 3 questions, you now have a firm understanding of an introduction to nonlinear relations.